11.4 Arcs and Chords. So today our objective is to use properties of chords of circles. Our warm-up is going to be to draw a circle with central angles, minor arcs, central angle, minor arc, major arc, and a radius, and then label all the points and name specific pieces. So let's get started. You know I have that really cool tool that lets me draw a circle. Let's see if it actually will turn out looking like a circle. Sometimes it looks more like an ellipse or an oval. Here we go. Okay, so, well, still a little bit more ovally, but we're going to go like this. If I go like draw this section, I can call the part from the center to the edge, either one of these, as the radius. This whole portion here, we can call the central angle. So remember, the central angle is at the center of your circle, and it's an angle. The smaller one is going to be your minor arc. This one over here is going to be your major arc. And then it says, and name each piece. Normally we encourage to actually like label that this would be like point A, and this would be point B. And then over here, you would have C, and therefore if you did your minor arc, we have AB, little arc over it, but your major arc, ACB, notice we now put C in it because that's the point on the major arc, and it's bigger, so that's your major arc. Okay, let's go through our definitions. Real quick, a nice shout out to Miss Moran, who gave me this little tip for my eye pen, so it should make it a little less loud when I'm hitting the little chalkboard, or the iPad, I guess we call it. Okay, our first one here is the theorem. If the diameter of the circle is perpendicular to the chord, so it's forming that right angle, then the diameter bisects the chord and its arcs. So that means that this right here would be congruent to this portion right here, and this arc measure would be congruent to this arc measure. Okay, so that's a very important theorem that we're going to use today. If you need to pause it to write it down, please feel free. If one chord is a, let's try it again. If one chord is a perpendicular bisector of another chord, then the first chord is the diameter. So this is kind of the converse. So if you find out that these are already perpendicular bisecting, that has the right angle, has these congruent marks, then this one here has to be the diameter. It's the only one that has that property. Okay, let's get started. So this uses that first theorem. So if the diameter, you see it's going through the center of the circle, is perpendicular, we see the right angle, then it bisects the chord and its arcs. So that means that this portion here has to be congruent to this portion here. So that means x equals 6. Okay, our next one up, you see again that you have a diameter. It's perpendicular bisecting, so that means these two have to be congruent. So I can set x plus 4 equals 3x minus 6. We're going to subtract x from both sides. I get 4 equals 2x minus 6. Add 6 to both sides. I end up with 10 equals 2x. And then we want to get x by itself, so we're going to divide each side by 2. So I get x equals 5. Okay, let's go on to our next one. Okay, here you see that you have a triangle on the inside with a side length of 12. You see that these arcs are congruent, so that means that this side length also is going to have to be the same length because it has the same arc measure. So this x has to be 12. Over here, you see that you have this angle, which is 115, and you have this chord, which is congruent to this chord, which means again that their arcs had to be congruent, which means that their angles have to be congruent. So therefore, this x equals 115. So because of that congruent mark that I drew on top of, I can erase it so you can see it. So those two, that means that those angles also have to be congruent. Okay, and then it said if the diameter bisects, let's read it again so I make sure I get it 100% correct. So if the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So you see that it's bisected the chord. You see it's perpendicular. So since this portion here is 75, that means this portion here also has to be 75 because the arc has been bisected. So 75. And then over here, you see that you have, we could actually relate it to vertical angles, but you have the same congruent marks, 2 on this side, 2 on this side, 1 on this side, 1 on this side. So that means that this angle and this arc have to be congruent to this angle and this arc. That means X has to be 120 degrees. Okay guys, let me know if you have any questions. I actually do have a theorem I wrote at the bottom. I probably should have given this to you a little earlier. I'll write it out again. So, you guys have it. So this is an extra theorem. It's not on your notes. So, in the same circle or in congruent circles, if 2 chords are congruent, then their corresponding minor arc are congruent. And the other one is if 2 minor arcs are congruent, then their, sorry guys, corresponding chords are congruent. Okay, so that was make it a little bit easier to see those last couple examples, but we still did okay logically. That's not a word. We did a nice job using logic to get where we needed to be. Okay, guys, let me know if you have any questions. I missed you. Thanks. Bye.